Blurb 5, more about base units and physics formula. Springboarding off of Blurb 4, it's a good idea to make a chart, something like this, in which the quantities, base units, and abbreviation for base units are listed. And you would continue the chart for the course as it continues, because there will be, as I said, about 14 or 15 of these quantities of physics. Why is the base unit of a quantity so important? There are plenty of other units that measure the same thing, right? For instance, in the case of speed in the SI system, in addition to the base unit of meters per second, there's other speed units: centimeters per second, kilometer per hour, meter per hour, centimeter per minute, etc., etc. Almost an infinite number, not really, but a great number can be developed. The reason is that base units must be used in physics formulas. In other words, the formula constants are based on base units being used. And also, when the base units are used, the answer will also be in base units. And this fact allows computation to be done without units. Now, if you recall the graphic model of a typical problem solving that we had earlier, something like this, where you start with data, you calculate, and then you come out with an answer. The data must always include units. And now we found out that the answer must also include base units. All right? And the data has to be base units as well. And if it is given in something else, then you have to so-called convert it to base units. But the thing that's interesting is that in the calculations, you don't really need the units to be carried along with the number. And the reason is that the answer will always be, or should primarily be, a quantity of physics. And being a quantity, and you having studied in the course the base units for the quantities, you will know what the answer quantity units are even before you attempt to solve the problem. In other words, if you're solving a problem for speed, where the answer is speed in physics, you're using the SI system of measurement, you already know the answer's units have to be meters per second. And that is without touching a pencil. So there you have it. If you're solving a problem that asks for physics quantity answer, and the vast majority of problems do this, you simply add the base units to that final numerical answer. There is no need to carry units through a physics calculation in order to know what the correct units are. And doing this would cause more chance of an answer error than not. Topics in physics are usually covered slowly enough that remembering the base units for the quantities currently under study is easy, because it won't be all the 16 at once. Keeping track of them by a chart is a great tool. Just a reminder, although it is not necessary as pointed out in this blurb, some textbooks and teachers will have you carry units through calculations initially in the course. And this is simply to emphasize that units may be manipulated in math just like the number. It is also useful to show how one can convert from a non-base unit to a base unit. More on that later. However, to me, conversion of units also, and certainly in homework and things like that, may be something left to look up sources such as on the web, Google, etc.